In this example here, we have scaled test scores from the New York State Grade 4 Common Math Test. And we can see that these scores are normally distributed because we do see that symmetric bell shape. The first thing we are asked to do is to find the mean test score. So to find that mean test score, I'm going to go into this normal curve and I'm going to look for the line of symmetry. So I approximated that line of symmetry about right there, that red line that I drew in. So now I'm going to go and figure out about where that is using these tick marks that are given to us on that horizontal axis at the bottom. So I zoomed into it. Between 280 and 330 is 50. That's 50, that's the distance between them. So hopefully you can see that that's 290. This is 300. This is 310, that's 320, and there's 330, I mean. So the red part that I'm marking as the mean, mean right there, that's a little bit bigger than 300. I'll guesstimate that that mean is about 305, that the average score for the student on this test, on this math test score, is about 305. The next thing we're asked to do is we're asked to estimate the standard deviation of this normal distribution. So I'm going to go in and I'm going to draw about where I think the inflection points are. So where the graph stops being turned downward and starts being turned upward. The upward part I put in green. So to give me what the standard deviation is, more specifically for the standard deviation will be that horizontal distance there in yellow. Standard deviation will be that, or blah, blah, blah. Sorry. Or I could use this one. It doesn't matter if you use the positive one or the negative one. I just wanted to point that out. I just prefer to use the positive one. So I'm going to go in and approximate about what I think that inflection point is right there. So this is maybe about 345 for that inflection point. So if I'm saying the inflection point is about 345 and I said that the mean was about 305, then my standard deviation I'm approximating is about 40. And I'm getting that by taking my positive inflection point of 345 and subtracting my mean of 305 to give me about 40. I know that's in yellow. I'll change it. But I'm saying 40 is about that distance right there between the mean and that inflection point. So let's tie this in with what we learned about the empirical rule back in, I believe, lesson 7. Yes, lesson 7. So I just went back to lesson 7. This is slide 3. Empirical rule, also called the 68, 95, 99.7 rule. I will start to unmute this video, but what we're doing here is what we're going to do now that we do have a normal curve. Notice here, look, it says good for the normal distribution, symmetric distribution, so it's all tying in now. We're going to use the empirical rule to help interpret the mean and the standard deviation now that we know it, and give the percentages for what's between 1, 2, and 3 standard deviations. So I'm going to just grab this screenshot and pull this over to what we're working with to help us write. Oh, that's so big. To help us write some interpretations for this. So what the empirical rule tells us is that at least 68% of the data will be within 1 standard deviation of the mean. Well, for us, 1 standard deviation of the mean means going 40 to the right of the mean and 40 to the left of the mean. So I'm going to take the mean of 305 and I'm going to subtract 40. And then I'm going to take the mean and I'm going to add 40. So subtracting 40 gives us 265 and adding 40 gives us 345. So we can say at least 68% of students scored between 265 and 345 on the grade 4 common math test. So that is one way that we could interpret the mean and the standard deviation here. I could also say, if I take it a step further and look at what's happening within 2 standard deviations of the mean, I would then need to not just subtract 40, but I would need to subtract the mean. I would need to subtract the standard deviation twice. So sometimes you'll see that written as whatever the mean is, subtract 2 multiplied by the standard deviation, which is why we had mu minus 2 sigma. I'm just saying that I'm going to subtract 40 again from 265, which is going to give me 225. So this is 305 minus 2 times 40, which gives me 225. And then I'll take the mean and I will add the standard deviation twice. It doesn't matter what order I write these things in, to get up to 385. And then I would be able to say that at least 95, this time it's 95 because we went 2 standard deviations to the right and 2 standard deviations to the left. At least 95% of students scored between a 225 and a 385 on that test. So let's give this some perspective of what we're talking about. The first comment that we made about 68% of students scoring between 265 and 345, that's just going to the inflection points. 1 standard deviation to the right and 1 standard deviation to the left. We're saying that about 68% of the data, which is most of the data, is between those 2 purple lines. If we want to take it out even further and go 2 standard deviations to the right and 2 standard deviations to the left, the yellow bar shows us 1 standard deviation. Going another standard deviation would be going another 40 all the way out to I'm going to the right, all the way out to 385, so going out to about right here. And then going another standard deviation to the left, so going out to 225, about right here. This is now saying that between those orange lines, 95% of the data would be between those orange lines. 68% of the data between the purples, and then 95% of the data between the orange. And if we went 3 standard deviations, then we could say 99.7. Almost all of the data would be within 3 standard deviations away from the mean. That's what the empirical rule tells us. And that rule can be used for only normal symmetric distributions.